Welcome back everybody to another live stream repair. Sorry for the background noise. I've got a rather long print running right now, and we've got a HomePod that's been waiting to get fixed up, so we're just gonna go ahead and ignore that. I figured if you want to hear and see what's going on, I put it up there in the top right for you, so anyways, we've got Steven's HomePod here with the classic no power symptoms. Doesn't do anything when you plug it in. Pulls about 5 watts of power from the wall. So let's get this fixed up. We've got 1748K on there, so let's go ahead and knock that out. Yeah. I started a print that I didn't realize would last 5 hours or so. Hey, good to hear it. That's what I put it out there for. It just seemed too easy not to do it. Granted, our first time getting into our first HomePod took like 2 hours just to get the top off, but yeah, the number of people that have emailed me trying to do the repair themselves, and they're like, yeah, I can't get this diode off to save my life. It's a lot. Once you get the feel for it, though, or until you get the feel for it, you can always heat up the underside of the board for like 30 seconds, get that board nice and warm. Hey, we've got power. And not the best offset, so we may as well give it some new filters. Y'all know how I feel about doing filters. I won't go over it again. But we will talk about what would happen if we leave them alone. That DC voltage at the bottom right of the corner is a reading coming from our subwoofer connected to the amplifier. And DC voltage is not good for your speakers. So, over time that'll get worse and worse, and eventually develop death farts, and possibly blow out the whole amp and bass speaker. This happens because of our filter capacitors. These naturally go bad over time, and Apple didn't do the best job making a design that accounted for that. So we're gonna get them swapped out. See if we can't get that DC offset a little better. I normally replace these if the offset's 50 millivolts or greater, and that went up to 41 millivolts, so it's pretty close, but then again, our 50 millivolt target's already pretty aggressive. It takes about 200 millivolts or more for issues to really start occurring. Oh, in some of the photos I've seen of people's attempts, like exactly like Monosurge said in the chat, you could tell people got pissed. Because like the diode's like all scratched to hell, and like the PCB is all scratched, and like things are like absolutely cooked. Here we go. That joint looked a little dry. Yeah, I was using some other low mount stuff at some point mixed in. And it almost acted like a magnet. It would suck the parts together. It sucked so bad. I hated it. Okay, so previously we were at 40 millivolts and growing. Let's see if we've got that improved at all. Sometimes we do all four at once if we're feeling lucky. I don't feel like messing around tonight though. There we go. The closer to zero, the better. So the fact that that is going down closer to zero and settling and staying relatively steady means that we've got that under control. So we can put this finally back together. You get out of there. Your day job is amplifier repair? Oh man. I would love to pick your brain sometime. Cause I don't know anything about audio amplifiers. I may sound like it, but I don't have any experience beyond what you've seen us do on the channel here and what you can basically find on Google. So I've got a little bit of a grip on it, but that's exactly how we got sucked into this. I just wanted a cheap HomePod. I didn't want to pay full price. Lo and behold, there's a demand for someone to fix them. and a few problems no one was able to fix. And I like a good challenge. So when I heard about death farts years ago, at this point it would have been years ago, when I heard about death farts, there was that YouTube channel, Oh It Me Nick, who had taken apart a HomePod and done some diagnosis, and he's the one that discovered that death farts were caused by too much DC offset. But he and everybody else at the time thought that it was because of the amplifier chip. It was the amp chip causing that. And something didn't really... I didn't really feel like that was right. So I was able to find a few suitable replacement amp chips and tried that, replacing those, and that didn't make a difference, of course. So I did more research on DC offset, and that's how I found this blog post talking about how DC offset can get worse with heat. So I thought, okay, we have no idea where on the amplifier this DC offset's coming from. What if I start heating up different parts of the board until we see the DC offset react the most to that? Sure enough, that's how we honed in on those filter caps that you see us replace. And that was, oh man, I wish I was recording myself when I discovered that. I was so stoked. Yeah, I think that's how I understood it. Is it's basically expected for a Class D amp to have DC offset from, I'm guessing, like what you're saying, the carrier, which I don't know what the carrier means, honestly. I'm gonna have to look that up, but and then it's the filter's job to remove that expected DC voltage. It just kind of, I don't know if you have any perspective on this, but you saw there's 4 filters there that are supposed to take care of this. And from what I could tell, it looks like it only takes one of those 4 for problems to happen. And it makes me wonder, did Apple, like, is this just like a rookie mistake that Apple made designing this thing? Is it an intentional design? Is this a common thing that we see in audio amplifiers? Or are we being unrealistic here with our expectations? Because you do have to remember, this isn't just an analog speaker, right? This is essentially 8 speakers. You've got a dedicated subwoofer, and yes, it's a true subwoofer. It goes down to 45 hertz. You've got 7 mid-range tweeter speakers, an amplifier for all of those speakers, which, mind you, each speaker has its own dedicated amplifier chip, an internal power supply, which is switching, supports 110 to 240 volts AC, and then essentially an iPhone 6 on top to run the whole thing. So, for them to run a few years at a time without nothing before something goes wrong, I don't know. Maybe it is unrealistic to think that there's nothing that should go wrong, but in that case, they should design them with that in mind, of course, right? But maybe they know that. Maybe they know overcomplicating this is asking for things to break after a year or two, and people are going to need to buy a new one. And they want to make it difficult to repair. Nah, that's too crazy. Yeah, I've considered actually, like, sending an amplifier board to someone for reverse engineering just to get a schematic out of it, just to make, like, just so we could figure out a few other issues with these. Maybe hack them. But from what I can tell, reverse engineering services are easily going to be thousands of dollars for a board as complicated as just the amplifier in this thing. So, my next route is, of course, keeping an eye out for a DIY audio amplifier board that we can essentially just drop into the HomePod, rip out the stock Apple guts that retains. I want the replacement amplifier, of course, to have AirPlay support, but you know, we can add Bluetooth, we can add auxiliary in, and you might be wondering, well, how are you going to add auxiliary in? Got a few ideas, but we won't spoil that yet. Yeah, that makes sense. And I would also expect, for how much, I've said this a million times in past streams, but it cost Apple $249 per unit to manufacture, basically from dust to your doorstep. It cost them $249 per HomePod. So for them to be selling them even at their original $350 MSRP, they're only making $100 on them. But that $250 cost for them to make it, they put some effort into these. So it's another reason why I like working on these and trying to keep them going. Yeah, no, we would definitely not. We wouldn't be keeping any of the original guts. We would be completely ditching the original power supply and amplifier and replacing it with something entirely third party that has AirPlay support, AirPlay 2 specifically, because I need that multi-room yo. And then one of the ideas that I had was repurposing the debug port on the bottom and making a dongle or an adapter or something that you can just plug into the bottom that would allow you to plug in a 3.5 or a 1/4 inch, or maybe even HDMI. It depends on what kind of amp we can find. And there's also still the power cable here too. We might be able to reuse that for something, for the power port. And then I think we could probably tune it. So there's two things. I think there's two main things. I think the room correction is probably icing on the cake, but there's two fundamental things that we need to fix to make it sound anywhere as close to original if we replace the amplifier with an off-the-shelf one. The first one is we need to figure out, I think it's called the Munson curve or something like that. They did something like that with the HomePods where essentially the human hearing can't perceive lower frequencies at lower volumes as well as higher frequencies. So the lower you turn the volume down on the HomePod, the lower it's going to turn down the higher frequencies, but less proportionally the lower frequencies. So like, let's say 20% volume is going to be 20% tweeters, but actually 30% bass, just as like a crude basic example. And then, whatever. The second part would be tuning for the actual speakers in the enclosure. That should be fairly easy to figure out, maybe, if we can take some sound samples of it and see how, I don't know. I'm sure there's people way smarter than me that hear these two problems and have very easy solutions for them already. So yes, that is exactly what we're looking for, an onboard DSP that'll allow us to do both of those things. The only thing I don't know about is how do we capture how it's currently tuned. The room correction I'm not as concerned with. That could be like a super extra credit thing maybe for one day.
I'm having trouble connecting to you. I'm having trouble connecting.
All right, we got this one all fixed up, and that is actually all that we've got here tonight. So, how's our print coming along? So there's this manufacturer called Arylic, and they've got what's called the Up2Stream HD DAC, and it's an AirPlay 2 compatible DAC. It's not an amp. We'd need to find an amp for it. I don't think they have AirPlay 2 like amps with the DAC. You gotta basically get the DAC and then okay. I am getting hungry, so that is all that we have got here and now. Mono Surge, it was a pleasure chatting with you, and I hope that we get to chat again soon. You really sound like you know your stuff, and 27 years in it, I would expect it at this point. Wow, that's goodness, about as long as I've been alive at this point. Hope you all enjoyed this live stream repair, and I'll catch you in the next one. Goodbye.